Hey guys, this is Mitch with Fine Point CGI, and today we're going to continue our horror game by building a dynamic light-based stealth system. So we're going to go through the process of creating a camera, creating our sub viewports, creating our mesh instances, and really building out our light system. Basically, the way it works is that we're going to take pictures of a sphere and we are going to determine how in shadow we are based off of the values of that picture. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing that we have to do is we have to design out exactly what we're going to be building. So as always, I like to design out what I'm trying to do before I actually, create it, because it gives us a good opportunity to talk about design and talk about how we're going to approach something. So here's what I'm thinking for our stealth system. So first, what I'm thinking is we're going to have a cube. Okay, and this cube is going to exist next to the player or inside of the player, and basically it's going to have a camera above it, and that camera is going to look at the pixels on the screen, and it's going to determine based off of those pixels if the user is in stealth. So it's going to be really simple, but basically we're going to get our camera, render our viewport to texture, and then it's going to come down here and it's going to read the pixels for lightness or value, and then from there it's going to average those values. Okay, and then it will return its values that it's going to have. And basically, then when we go back to our enemy AI can actually be adjusted to check for that value. So let me open up my enemy AI here. You guys remember this guy here. In our patrol state, our wait state, our chase state, and our hunting state, when we look around for the player here, what we can do is we can check the player's light value. And basically, if we check the player's light value, if they see the player, then we can say that, yep, they are visible, if that makes sense. So we can do this, which is funny because I actually did it twice. Look around for player, look around the area for player, but that's okay. And basically, we can actually check our light value. Now, I know that this is probably not, I might need to readjust the design of this a little bit, but you get the idea of what I'm trying to say. And same thing with like patrol or like these guys here. Basically, we would say on area enter, what is the character's light value? You would check that every frame. And if the light value changes enough, then we know that we need to chase after the player. So I think that's going to be the plan. I know that this is like a really simple system, but that's basically how we can do it. So let's jump into Godot and let's code this out. Okay, so first we need to create a 3D scene. So let's go to scene, new scene. Let's click on 3D scene, and you'll see that we have, of course, our small little scene here. And how we can actually approach this is by creating a new viewport and by adding a camera. So what we'll do is we'll double click our node 3D. We'll rename this as light detect, and then we'll right click, add in a child node, and let's add in a mesh 3D, and we're going to make that into a cube. Now you could make it into something else if you want to use like a capsule mesh. That might be better for getting a more accurate representation of light, or maybe a sphere would be good because it would give you a very accurate estimation of light. So it's up to you on what kind of thing you want to use. In my case, I'm curious how a sphere would look, if it would be good, because before I used a cube because, a cube is easier to work with in my opinion, but we could do a sphere and just kind of bring down the radial segments like this to help with, resolution. That way it's not so bad. I think that will work. So we'll do this, and then what we can do is we can right click, add in a child node, and let's add in a sub viewport container. And what this is it's literally a container that houses your viewport, okay? And I know what you're asking. Well, okay, but why not just add a camera, right? And the reason why is you have to have a viewport to render out a camera as a separate object, if that makes sense. And the reason why I want this sub viewport container instead of just doing a regular viewport is because I want it for debugging purposes. We need to have debugging in our game so that way we know what our actual light looks like on that camera, if that makes sense. So we'll drag this guy out to be, I don't know, about this big, give or take. This is about how big it'll be on the screen. And then we'll right click, add in a child node, and add in a sub viewport, which it actually already has right here. So we'll add that guy in. And then we'll right click, add a child node, and add in a camera. Now you'll see that we have our camera right here. And what we want to do is we want to change it to be a orthographic camera. And an orthographic camera changes the perspective of your image, if that makes sense. If I drag this guy 90 degrees down and I pull this up like so, and then I hit preview, you'll see what we're looking at. If I click on my camera and I turn off orthographic and I go to perspective, you'll see how that changes how it looks. Everything kind of has a little bit of a perspective view to it, but I'll just undo it all and we can go from here. So you can see how we have this nice dark rim right here, and that's kind of what we're looking for, right? Is the ability that we can read these pixels and then we'll read these dark values, right? It'll be really nice, trust me. So next, what we'll do is we'll right click our light detect and attach a script, and we'll just call it lightdetect.gd, and I'm going to get rid of that space because I just don't like having spaces in my scripts. And what we'll do is first, I'm going to create a variable called light level. So we'll say var light level, and we will make that a float. And then we'll make a function because we don't want to run on process. Then we'll come down into process and we'll say var image, and we'll say that is a type image like that. And we'll make that equal to get node, and we'll pull our sub viewport dot get underscore texture dot get underscore image, and that's going to pull back our image from our viewport. Okay, so we're basically taking a screenshot of our camera. And then what we can do is we can create a list of floats because we're going to need to average all these floats to determine the general lightness of an image. So we'll just create a list. So var floats is of type array, and we'll make that array an array of floats, and then we need to loop through our image. So we'll say for, and now we need to loop through our image. Okay, so we need to get the height of our image and the width of our image and then loop through each individual pixel. So let's just grab our pixels and loop through it. So for y in range 0 comma image dot get height, and that will pull back our height. And then we got to loop through our x-axis as well. So for x in range 0 comma image dot get width, and then we can pull back our actual pixels. So think of an image as an array of pixels, right? It's a two-dimensional, it's a vector 2 of pixels, right? So 0, 0 is the uppermost left of a pixel, right? And what we're doing is we're literally iterating through the top and iterating from left to right, top to bottom of all of our pixels. Now, part of the problem with this is that it's going to be very slow. So we have to be very careful with the resolution of our image, because if it's really large, this is running every frame probably or every call. So it's going to be extremely slow. So we have to be careful of that. But let's pull back our pixels. So var pixel is equal to image dot get pixel, and we have to pass in our x and y value. So x comma y. And then we can pull back our light value. Now, a pixel in an image is the R, G, and B value of an image, and we need to get the average of those three values. So we'll just type var light value is equal to parentheses pixel dot r plus pixel dot g plus pixel dot b. And then to get the average of those three values, we just divide it by 3, and that will return us a perfectly average value of that pixel. And then that's how we can determine the light value of that pixel. And then we can just append it to our floats. So floats dot append, and we'll append our light value. And that will allow us to have a light value. Now, this is great, but now we have a giant array of pixels and their average light values. And that's great, but that's not super useful for us yet. We need to take an average of all of those values and basically pass that back, okay? Now, that means we're going to need to loop through that array and average everything out. Now, I'm going to create a new function for this because honestly, in the future, we might want to take the average of an array somewhere else. So we might want to create a utility function for this. So func average numbers, and using this function, we can basically get the average. So we can just say var sum is equal to 0.0. And then we can just say for n in numbers, because we're going to assume that it's an array. And honestly, we might want to make sure it's an array. So we'll just say array. And we could pass back our float value as well. And that'll kind of help solve that. Now, what we can do is we can just say sum plus equals n. And then we can just return our sum divided by our numbers dot size. And that will get us the average. And then we can just return average and then pass in our floats array, and that should in theory work. And I'm going to save this as a scene in our scenes folder, and there we go. Now we might need to reorganize this a tiny bit eventually, but right now it's okay. So I think that will work. So let's head over to our light detect scene here, and let's click on our viewport. And instead of it being 512 by 512, what we need to keep in mind about our size of our viewport is this is the resolution that we're going to be refreshing at every second or every millisecond or every frame, depending on how we want to set this up. So we want to make sure that this is a low enough value that it doesn't absolutely destroy our performance. And to put it in perspective, if I bring up a calculator real quick and I go 512 multiplied by 512, you're looking at 262,000 iterations. And that is an absolute mammoth of amount of iterations, right? Whereas if we did something like 32 multiplied by 32, we're looking at 1,024. And that's a lot less iterations, if that makes sense, that we're running through. So how we can kind of show this, if I turn on transparent background because we want transparent background, and if we come to render target and we do update mode always, that should hopefully, there we go. If we just kind of adjust this a little bit, you'll see the resolution of our image. If we change this to something like 64 by 64, did we really lose that much resolution? Not really. We can still tell if our color values are good, right? So we could really go down to something like maybe 16 by 16. Is there really a big difference? Not really. I wonder if we go down to 8, is that going to make a huge difference? This one, we're starting to get a little bit into the, okay, it's getting pretty bad territory. So we might not want to go with 8 by 8, but I'm going to go with 8 by 8 just because of the performance gain that we're going to get from this. So if we take 8 multiplied by 8, that's 64 versus our original of 512 by 512. And we're going to get generally the same values, right? If you wanted to go 16 by 16, I won't be mad at you. You can totally do that, and that will work as well. But just remember that your accuracy versus your performance. And it's up to you on which one you want to have. But for me, I'm going to go with 8x8 or maybe 16x16 if I don't like the 8x8. But I think that will do. So now we're going to hit Control S. We're going to go to our character and we're going to add in our light detect script. And we'll just kind of drag this guy up, and you'll also notice that that thing is quite large. If we actually hide our mesh instance, you'll see how big this object is. And we could make it this big if we want to, but the only downside to making it this large is that, remember, if they are a single pixel here in light, then it's going to drastically affect them later because of the accuracy of our system. So let's come into light detect. Let's select our mesh instance and let's just make it smaller. That'll help with accuracy. That'll help with things like that. So, and it'll actually make it a little bit more fair to the user, right? We always want to err on the side of the player versus on the side of the system, because if you err on the side of the system, the player can feel like it's not fair. Like, why did this enemy see me? I was in shadow. Even if you technically weren't, we want to err on the side of the player over the side of the game. So we'll just take this and we'll just make this like 0.3 by 0.3, and that will help with erring on the side of the player, so you can see how much smaller it is. And something else that I've noticed is, and granted, I will have to look at how to fix it, but something I've noticed is the shadow of this mesh instance does affect this guy. So if I turn it on, you can see there's our guy right here. You can see how the shadow affects this guy. Now, I am talking to some of the developers about this to see if there's a way around it, but right now what I'm going to do is I'm just going to hide this object and just have it not exist, because right now it just doesn't seem like it wants to work. So we might come back to this later, or maybe I'll do, hopefully they can get back to me soon. But right now I'm just going to make it so that this object doesn't exist, and we should be good to go. So now what we can do is we can go into our player and we come up to the top and we say var light level, and we'll make that a float. If we come down here and just somewhere in our physics process, we say light level is equal to get node, and we'll grab our light detect node dot, and I believe it was called light level right here. So we'll grab this guy and paste, and there we go. And if we just print our light level like that, let's see what happens if we hit play. Now you'll see we get zeros, which is not ideal. So let's see what is going on. If we come into our light detect, so I'm going to put a breakpoint right here, and let's take a look. So we'll come down like this. And the easiest way to do this is F11, by the way. So I'm going to hit F11, F11, F11. It's getting my pixel correctly. It's averaging the light value correctly. So that's good. And it looks like it's appending it correctly. So let's throw a breakpoint here and hit play. And it looks like it has all the data we need. And we're returning. Oh, it's because we're returning it. So we're supposed to take this light value, put it here, and equals average. I don't know why I returned it. So now if we refresh this and try this again, there we go. That's what we were looking for. So you can see how we have all of these values here. This is basically saying, yep, our light value is this, okay? And then what we can do, I can't believe I made that mistake. What we can do is we can come to test scene. We can come over to our scene here. Let's add in the directional shadow. So we'll come into our directional light. We'll go to our shadow here and add in some shadow. And then let's hit play. And we head over here and we crouch underneath here. You'll notice that, well, nothing's really changed. It's still 0724 right here, even though we're underneath our shadow. See, we're actually in our shadow. So this should work, right? But it doesn't. So why not? Well, the reason why is because the camera itself, this camera here, is staying at its position. We need to actually move it with the player because unfortunately we can't just make it a child of the object because for whatever reason, Godot doesn't translate that camera with the viewport. My guess is it has something to do with different 3D spaces would be my guess, but I'm not fully sure. But what we can do is our mesh instance 3D, this little guy here, does move with the player because it's outside of this viewport. So the big issue stems from the viewport for whatever reason. So what we can do is we can come into our light detect and in our process, just move our camera with it. So we can say get node and pass in our camera dot global underscore position is equal to vector 3, and we'll pass in our mesh instance. Now we could just go and get node for mesh instance, but what I'll do is I'll just say var mesh instance is equal to get node mesh instance 3D, and I'll put a little colon here, and that'll help with giving us the type handling. And we'll just come over here and say mesh instance dot global underscore position dot x comma, and for our y value we'll basically just grab this guy, paste y, and we need to offset this by a little bit, so let's just plus 0.3. And then for our z, let's basically just grab this guy again, paste it, and do .z. And the reason why we need to offset this guy is because if we don't, our camera will snap to the center of our sphere and our entire code will break because it will no longer take photos of our sphere, if that makes sense. So now all we need to do is if we hit play, let's take a look. So you can see as we move, the value is now changing, which is good. If we run over here and we crouch, you'll see now we have 0.2, 0.3, which is good. That's what we want. We want our values to say, hey, we're 25% in light. And that's perfect. That's exactly what we want. So if we head over here, you'll see we have 0.7, 0.3, 0.2, 0.6, 0.7. So that's awesome. So that's basically how we create our light system. So if that's what you guys were looking for, you guys can stop right here and continue on your day. What I'm going to do next is I'm going to update my enemy to actually respect my lighting system. So we'll come to our enemy.gd, and in our states, if you remember, we actually have some sections here where we're searching for if our player is crouched, if I remember correctly. So if we come down to, I believe, check for player here, we actually have a whole section in here where we are checking if the player is in earshot close, if the player is in earshot far, and if the player is in sight close or far. And what we can do is if the player is in sight close, we can actually check our player for their light value. Now, we do have access to our player. If I remember correctly, up here in our result, we actually check if our result collider is in group player. So really, we could pull back our result.collider. So if our player dot, and if I remember correctly, it is light level is greater than some kind of value. Now, if we look at our output, when our player was in shadow, we had about 0.25. So we might want to be a little bit liberal with our light values. So let's set it to something like 0.3 maybe. So we can say if they're in that shadow, we're good. So if the light value is greater than 0.3, then we can chase our player. We've seen them, we can chase after them. If we're in far sight, instead of just checking if we're crouched, instead, let's check to see if they're in light value. If they're crouched is equal to false, and if their light value, so if result.collider dot light level is greater than point, I don't know, probably point 0.6 or something like that. Because if we look at our default light level, we had, let's see, 0.707. So yeah, I think point 0.6 would be fine. So point 0.6, then we can hunt after the player. Okay. And we could also check if the player is crouched. So we could just basically duplicate this entire section here and say, well, even if the player is crouched and their light level is above 0.7, then we could actually say, hey, we're going to hunt after the player. And that would allow us to have a little bit more flexibility and a little bit more dynamic system. Because if I'm crouching and I'm in the middle of daylight, you could still see me, right? It might be a little bit harder to see me because I'm, slightly smaller, but generally speaking, you can still see me. So with this, we should be okay with testing this, and it should work in theory. So let's hit play and let's see how it goes. So we'll hit play. He sees me. I go in here, I crouch, and I get into darkness. So I'm at 0.26. So he's waiting. It's going to head back, and now I should be within his view cone, and he doesn't see me. So if I crouch, he's waiting. So now I'm in his view cone, and he doesn't see me. If I uncrouch, and now I'm inside of his view cone, he doesn't see me. Perfect. So that's exactly what we wanted. Now, something else that you'll notice is a bug is I'm crouched right now, but I'm not holding control. Okay. If I move, I can move at full speed. If I hold crouch, I can't move at full speed. So that's a problem. That's a bug. That's definitely a bug and definitely not ideal. So what we can do to solve that, and let's go to our character and let's scroll down and find the section for that. I believe it's right here. If crouched, do these things. We can take a look at where we're doing our raycast. Let's see. We're doing a raycast right here. So if we're crouched, we raycast. If result is greater than 0, then we'll uncrouch, and that's fine. Crouch is equal to false. Crouch is equal to true. If action pressed crouched, see that right here? Here's where we're doing our speed change. So let's hit Control X. Let's get rid of that and just say if crouched, then speed is equal to crouch speed. And that should solve that problem. So no matter what, your character will actually be at crouch speed if you're crouched. So that'll help solve that problem. So now if we hit play, we run over here, we get crouched, we duck down here, and we let off our crouch, you'll see that we are now back to our regular speed. So that works perfect. Awesome. All right. Now, something else, a little bit of housekeeping that I wanted to do is inside of our enemy, there's a section here where we're finding a bunch of nodes right here. And what we can do is we can add a decoration to help us out with setting this up a little bit better. So we can actually use the @onReady, and this will run on ready. And then we can basically just say : equals and grab our navigation agent 3D. And that should do it. So now we can just get rid of that guy. And we can do the same thing with our patrol timer here. So we can do : equals and then pass in our patrol timer like so. And we can use the decoration @onReady. And that will solve that problem as well. That just kind of, helps with running things on ready instead of running them in our ready function. We also can do the same thing with these current states as well. So let's grab that. So we'll grab our waypoints right here like that. And we can do the same thing with our player as well. So I'll grab this guy. And where's our player? : equals, paste. There we go. And then we can get rid of these guys. We could just add the decoration on ready for that. So copy, paste, space, and I believe there was one more. Let's see. I actually think I got it. And I'm going to move these guys up to be with the rest of these on readies, like so. That way I actually start organizing my code a little bit better. We'll get our waypoint index down here so it's out of the way. There we go. And I think that will do it. I think that'll be good. And we can also do the same thing with our current state. So we'll just do that and we'll add an on ready as well. There we go. And that should do it. That's a little bit more efficient. Somebody commented and saying, hey, you should do it this way. It's a little bit better looking, a little bit easier to follow as well. So let's try that and let's see. And you'll see that I got an error, so we need to do an on ready for this guy as well. Export, there we go. And if I hit play, there we go. And that's a little bit easier, a little bit more efficient than what I wanted to do before. So I think that will work. And I think we'll be good for right now. Hey guys, Editor Mitch here. So something that I missed is if you come into your sub viewport and you come over here and make sure you check stretch, okay? If you turn on stretch, that will help a lot with your debugging and things like that. And I'll show you what I mean in a second. And also make sure that you change your camera's size to match your new small ball size, okay? And what I mean by that is if we were to have this at the original size, which was about here-ish, if we look at our sub viewport, you can see how small this little guy is, and that's a pretty large problem. So that's something to keep in mind. So we just want to make sure that we set this to a nice small one, and then we can set this to, you know, back to our 8 and 8. And I think actually we'll go with 16 by 16. And we'll also need to make sure that we have our camera, not really, so we do need to change this to be just a bit smaller. I don't think I can go any smaller than that, so I actually might need to just make my mesh just a touch bigger. But just fool around with it and try to get it to fit just right for your sub viewport. So it should look like something like this. And then when we hit play, you'll see in the upper right hand corner up here, we actually have our ball. So we can run in here and then crouch, and you can see our ball gets darkened. And that's kind of what we're looking for. And you can see how the value down on our console here is at a 0.032. And that's a lot better because that allows us a lot more margin with our hide. So if I'm kind of like here, you can see I'm still considered stealth, and that's putting a more advantage on the player. So that's just something to keep in mind. But that's all I had for you. So let's go ahead and finish the video. Awesome. So that's basically how you create a light system and how you integrate it with your character controller. So in the next video, providing that I'm able to get it done, is creating a dynamic sound system so that the different objects that you're on will make different noises and produce different sound levels. So look forward to that because that should be a lot of fun. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.